Hi, my name is Matthew Poes with Poes Acoustics. As you know, I've been doing a series of videos on soundproofing, and in many cases I'm covering what I'm actually doing in my soundproof theater in order to discuss basically methods of soundproofing. But a lot of this is designed to be more universal than what I'm doing. I'm covering the range of methods you can use and how they work to help hopefully inform folks on what they're doing. Now, a big thing I've been trying to do, and in part this is because this is something that I've now learned over the years of doing soundproofing, is basically how deceitful this industry is. I mean, I'm sorry if I'm calling some of these companies out for what they've done, but I actually think it's intentional. And some of the most honest companies, I thought, that were putting out product ratings with scientific tests behind them that, yeah, look too good to be true, but I looked at it as, hey, what you learn in school and what happens in the real world don't match, and so it's reasonable. I don't think so. I think that what you learned in school in this particular case was right, and what these companies were doing was in fact gaming the system. So let me start with something that I mentioned in another video that I did on doors. The laboratories are not as accurate as I thought they were. They're not as accurate as they should be. So these labs, they get, I believe it's called NVLAP. It's a national federal government agency whose job it is to make sure that all the laboratories are testing in accordance with certain typically they're ISO standards or something similar to that, SAE standards it could be, but in this case it's ISO standards that allow them to give similar results across all labs. So if I take a floor assembly, a wall assembly, or a door assembly to Riverbank Labs, a very famous lab for doing this kind of testing, been around forever. I think the laboratory itself is over 100 years old. And I get a result. We'll say it's a door. That door assembly has an STC 35 rating from them. If I go to another lab, NWAA Labs for instance, and I have it tested there, I should get the same. Maybe it'll be a point different here or there, but it should be the same. If it's the exact same assembly and it was sent to one and sent to the other, and they're using an industry standard approach, and a government inspector went in to say, how are you testing, and show me all the equipment you use, and like when was the last time the equipment was calibrated and how you do the result, you know, go to NWA Labs and say, you do it too, show me everything you're doing. We should expect the results are the same. Well, it turns out they're not. They're different, and not a point or two off. They can be 10 points off. It's insane. Some of these labs have a margin of error of plus or minus 6 points. And as a result, you could see at the extreme end of that, that could mean in theory a 12-point difference. Now, you wouldn't in practice see anything quite that extreme, but we do see, in fact, 5 to 6 point differences. But what we also see is that companies capitalize on chance, basically, by having products tested over and over again. And they take the worst results of what's called the standard assembly, and that would be, just as an example, a cheap normal door or a cheap normal wall, and they take the best results of their assembly, and they compare the two with a graph. Green glue is very famous for this, and they show you results that will say, if you do a, I don't know, steel studded wall with decoupling and 2 layers of drywall, and on one you don't use green glue and on the other you do, you will see a 10-point difference. You will not see a 10-point difference. That is insane. In fact, you will only see about a 2 to 3 point difference. And so for a long time I kept thinking, again, you know, the physics, the theory behind the physics may not be what happens in real life. Maybe there's some things happening with products like green glue, dampening product, that allows for a greater level of decoupling than you would expect to see based on theory. Well, no, the theory holds up in this case, because once the product gets independently tested in a proper way, what you see is that if you include the margin of error around this, you know, yes, the green glue assembly is definitely better. Product works. It just doesn't work that well. To be honest, next to nothing works that well. To see a 10-point improvement in a wall would require making that wall substantially heavier and substantially bigger, deeper basically, bigger air gap. So what that means is that there are companies out there selling assemblies, basically. They're telling you how to build walls, and they're rating them in ways that are completely bogus. I'm not going to name names in this case, but there is a company out there that does not make products. They just sell other people's products. But they do tell you they have different leveled walls. One of their walls has an STC 72 or 73 rating, depending on whether you use steel or wood studs. And it's basically a double stud wall with 2 layers of drywall, damping product added to it, and insulation. That wall actually is STC about 60 to 65. That's what the real rating of that wall would be based on proper independent testing. that number of 7273 is insane. And here's why I know it's insane. One of the laboratories, NWA Labs, has about, I believe they're 22, 24-inch thick walls. They are double stud steel walls. They are filled with insulation, and they have cement board in multiple layers on both sides with drywall on the outer side. That wall is about STC, we'll say 75, maybe STC 78. Now, how is it that using a material that has twice the weight of drywall in multiple layers and having an air gap that goes from about, let's say 8 or 9 inches to 22 inches only gains you 5 or 6 points? The answer is it doesn't. It gains you easily 10 to 15 points, which means that other wall can't possibly be doing what it's being claimed to do. So this gets us to the big lie in the industry, because yes, these labs are not as good as they're supposed to be, but the big lie, the real problem, is floors. So there's two ways we look at floors. There's STC, that's sound transmitted through the air through the floor. When you're playing loud music, for instance, in your theater, and you don't want people below you or above you, technically that's a floor ceiling assembly there too, to be able to hear what you're playing, you would be most concerned with STC. Now, if you don't want to have people hear you walking across the floor, or you're in your theater and it's in the basement, let's say, or the first floor and there's people above you and you don't want to hear your kids playing with their cars up above, that's actually called IIC, Impact Insulation Class, STC, Sound Transmission Class. IICs tend to be lower than STCs and the curves look different. They're not really a comparable number. So the way that you improve those is similar, but not the same. IIC is improved dramatically by decoupling. STC is too, but not as dramatically. IIC is not improved by mass, pretty much one bit at all. In fact, a very rigid, massive structure will have a very low IIC. A cement slab that is 2 feet thick will transmit sound like nobody's business. On the other hand, a couple of layers of tongue and groove, decoupled from, we'll say the typical support beams that you have, decoupled from a couple layers of drywall with insulation, will have a very high IIC. But it actually might have a lower STC than that big cement slab did. Depends. I mean, some cement slabs actually don't have a particularly high STC, but the point is that the mass is not making as big a difference with IIC. It can actually make things worse. So then you've got a problem. You'll go to the store, you have an apartment and you've got an HOA and they say you need to hit a certain number, or you're building a soundproof theater and you just want to hit a certain number. Or I teased about my brother who just didn't want to hear his kids playing upstairs and he ended up putting cork in and it didn't work. And the problem is that they'll tell you that these assemblies have like STC 70s. I've actually seen some, they're like STC 80 and 90. The IICs will often be anywhere from 50 to 70. And they'll say all you got to do is put in this really thin material and you get that number. What they don't tell you is a couple things. One, the number is probably a lie. There probably is no test that actually showed a number quite that high. Or if it did, it was probably using a lot of, there's a correction factor, especially in laboratories that have problems because they're older and they have noise problems and you name it, there's a correction factor that's put in to correct for some of those deficiencies in the lab itself. And that can end up giving a boost to a product that isn't really there. So that's one potential explanation. But the other could be that they might be telling you you're going to get an IIC of, let's say, 65 for this floor. What they didn't mention was to achieve that, you need a 1 foot thick slab of concrete. You need to put in a layer of this material. You need to put in then another layer of concrete. Maybe it's a 2-inch layer. And then you need to put in another layer of this material. And then you put in your normal flooring, and the flooring has to have padding under it, on top of what you put in, this soundproof mat. And then you get the STC 65 or the IIC 65 maybe, if it's really, really good, that they're claiming. Well, you didn't do that. Nobody's doing that. That's the kind of thing you do in commercial buildings. And again, you're probably still not going to achieve that crazy number that they came up with. So these floors are a big lie. And if we kind of understand that and get back to right size numbers, really, really well done floors will probably have an STC of between 50 and 60 and an IIC of between 45 and 55. And to achieve that in my own theater, because it is actually pretty important that I do that, what I'm going to do is you've got the normal floor trusses. I'm going to put in, I'm not going to put in rubber isolators here. You see that from some company. I think Oralex makes that. I don't happen to think those work all that well. So I'm going to put in a layer of tongue and groove. If I can, I might actually do 2 layers of tongue and groove with green glue, but it adds expense and there are some potential weight concerns. So I don't know that I'm doing that, but at least the one layer. Then I'm gonna put in special isolators. Now in this case, I'm actually gonna use those hush frame rafts that I mentioned before. And I expect those to work well, but you can use special rubber blocks too. There's even a mat, I think it's called a rim from Kinetics, and the rim product actually comes with insulation and then the rubber blocks, and you just roll it out. Very simple to use, works well. It's just expensive. So that would be an option. In my case, I'm going to use these rafts. I'm going to put down insulation, just like that rim product would have had, but in this case, it's a little bit more manual. I'm going to put down another layer of tongue and groove. I'm going to put down then on top of that another layer with green glue. On top of that, I'm going to use a layer of convoluted rubber or recycled rubber, something like that. And then on top of that, we'll go the flooring material, which I think we're going to do luxury plank vinyl, which actually is pretty good for sound resistance, but you could put in tile, wood, doesn't matter. There is a little bit better sound improvement for STC if you use tile or even potentially thick wood, as there is over something like this vinyl product, but actually a lower IIC. And the reason is because tile is very dense and it tends to transmit sound. I mean, you guys know what do shoes sound like, especially dress shoes clacking against tile, right? Very loud. So you can see why that would have a problem with impact noise, like walking. So that particular assembly, which is pretty crazy, to be honest. You're talking about at this point anywhere from, I would say 3 to 4 layers of anywhere from 5/8 to 3/4 inch thick tongue and groove material, green glue. Those rafts are like 2 inches thick, so there's a 2-inch air gap being put in there with insulation. It's decoupled with silicone decouplers. That's because that's how the raft works. And I'm at best looking at maybe STC 60 and an IAC of, I think, 50. How come all of that only gave that? Well, because like I said, the numbers out there are a lie. They're not accurate. And that what I'm telling you, which is a very substantial floor assembly, is probably realistically close to the best you could do. The next step up from what I'm doing to really see a substantial, like a 5 or 6 point improvement, would actually be that instead of putting in that second layer of wood like I'm talking about, you would have either concrete or gypcrete poured down at about 2 inches thick, 2.5 inches thick. You might do an extra isolator, even after those rafts. That would give you about a 5 or 6 point improvement. Now I actually priced that out because I was thinking of doing it and I thought it was a good idea. And the price for that was about $5,000 to $6,000. Now that was not for the whole floor. That was to have somebody come in, lay down. I was going to use Maxon as a company that does this. I was going to lay down their acoustic isolator on top of that second layer of, so I was going to have tongue and groove plywood, the rafts with the 2-inch in insulation, tongue and groove plywood, a acoustic mat that Maxon sells, and 2 inches roughly of gypcrete poured down. That would probably get me to about an STC 60-65 in that range, probably closer to the 65, and the IAC actually would be probably closer to, I'd say high 50s, low 60s. So that would be really good. But it was actually going to require a bunch of things. So it was the higher expense, the $5,000 plus. The floor joists themselves actually needed to be uprated. So they already were uprated one level to handle the fact that they were being used to support this second floor. They were actually going to need to be uprated one level beyond that. So that had about a $3,000 or $4,000 increase in cost just for that room. They were only going to upgrade those in that area. When all is said and done, it was like a $10,000 upgrade for 5 points. So I decided not to do that. And I've actually been told by a couple of folks to do this kind of testing. I might not actually see a difference. Like it's totally possible that the assembly, which I'm doing, which is it's a level beyond what the hush frame company actually tested, might be about within a point or two of that gypcrete floor that I was talking about. And if that's true, then I saved a lot of money and ended up getting a really good floor. So that's flooring. It's kind of a boring topic in a sense, but actually our floors and ceilings tend to be our weak points beyond the doors and windows. And like I said, the industry is just so full of lies that it's hard to figure out what you're supposed to do. So I really was hoping that, after having gone through this before and recognizing how deficient the typical assemblies are out there and how much they don't work, that I could help to better kind of right-size people's expectations and to realize that if you need a substantial amount of soundproofing between floors, this is another one of those like the door, you got to step up. You've got to do something substantial. In this case, this 2-inch isolator block with insulation is how much of a step up you need just to get to a substantial amount of soundproofing. So hopefully this was interesting and informative. Like I said, there's gonna be more of these. So until next time.